This next lesson is a little difficult to communicate. What I'm going to walk you through is the process of making what I call a ribbon bowl. This is definitely thinking outside of the bowl. Here's a typical profile, just an S shape. Now if I duplicate it on the other side, I can get kind of a funky looking form. You know how to design something from this. You overlay the rectangles and figure out the segments and so forth. But what if we want to do something different? Instead of an open vessel, how about designing something where one side overlaps? It crosses over, something like this. Well, obviously this can't be turned, but there is a way to build it. Now just for fun, let's take that same profile and put it horizontal. Now I have a completely different shape, but using the same set of curves. Instead of having a conventional bowl or vase, I've got what I describe as kind of a half bagel or a half donut shape. But the overlay of rectangles to do all my calculations, that all works out to be the same kind of process. Here you can see I've numbered the rings and I've put marks indicating the outside and inside diameters for each of these rings. To achieve the S shape, the S on its side, some of my small rings are on the same level as some of the bigger rings. Now this red line here, this is one ring, about 24 inches in diameter. It's not a wide ring from outside to inside. Inside that large diameter ring are two other rings, a small one in the middle and a middle-sized ring, all on the same level. So I've taken all the information off this, all the measurements, and I've just inputted them into an Excel spreadsheet program. Here's my numbered layers, my diameters measured from the blueprint. I've decided to make all my rings with 24 segments. The Excel program did the calculation, gave me my segment lengths, and my segment widths, I just took those right off the blueprint. So this cutting list, which was done in Excel, I could have done the same thing with just a piece of paper and a pocket calculator. I'm going to use walnut. This is from a tree that came down in a big storm about 12 years ago. I've been storing and drying the wood ever since. These boards measure almost 7/8 of an inch thick, but I've actually made my blueprint with layers 5/8 of an inch thick. This is because after I've built my initial rings, I'm going to split them into two rings approximately 5/16 inch thick each. My design has two rings that are very large, wide rings from inside to outside. In those cases, I don't like to rely on just the hose clamps. I individually glue these segments together to ensure plenty of pressure in those large glue surfaces. Here's an example of using glue cauls in order to be able to properly position my clamps to push all that glue out. You can see where this wide ring goes in the bottom of my plan. Once I have all my rings glued together, I'm running them through the drum sander. I want nice smooth surfaces on both sides of all the rings. It's not a coincidence that the largest rings barely fit through the drum sander. This is one method to split rings using a table saw. Do not attempt this unless you're very experienced working around a moving saw blade. To get a good smooth cut requires keeping that ring very flush to that vertical panel. You have to keep a firm grip on the ring. You have to be in control. You have to move it through the saw blade smoothly and have a nice smooth exit. This technique requires a lot of confidence and very sure hands. Now here's another way to split rings using the lathe. Some dabs of hot melt glue hold this ring onto this backing plate. A marking gauge will give me an indication as to the center line. A thin parting tool, wiggling the parting tool back and forth to keep the kerf open to reduce heat. This is another way to do it. All my split rings had one side perfectly smooth and ready for glue, so I'm just joining those back together. All the split rings have now been paired up. I'm now stacking my rings into my form. I've got two different stacks going here. That requires two different size sanding blocks. I've found that getting a good bond when putting together large diameter rings can be a challenge. Here I'm using the stair steps and applying lots of spring clamps. It's a lot more effective than just trying to press one ring against another. This stack of rings here, they were put together with spring clamps. They're going through the drum sander, getting ready to go on this base. This is the area at the bottom of my blueprint. And these two pieces here, those represent the center area of my form. I've reduced this whole turning now to 4 pieces. Because I haven't rounded my form, I haven't eliminated the stair steps, I'm able to use quick clamps in order to attach this large stack of thin rings. To glue in place that center post of rings, the small stack, I'm using my tailstock as a clamp and a centering device. To turn a smooth surface on the inside of this construction, I used a combination of a bowl gouge, a carbide tipped tool called an eliminator, and another carbide tipped tool called an easy rougher. When turning so many glue joints, carbide seems to hold up much better. I'm working at trying to achieve a wall thickness of about 3/10 of an inch in this area of the turning. I've got one last glue job to do to join these two components, and then I'll have my completed form. The diameters have been turned to match each other. The inside of that last form was sanded. The blue tape helps me align things rotationally, and my fingertips can perfectly center things. Okay, now I'm back at the lathe. And get rid of this faceplate finally. Get rid of the MDF. And then I'm going to just get rid of all the stair steps on this walnut. Turn everything down so I've got smooth surfaces so I can start to work on nice smooth curves. I've got no way to check my wall thickness conventionally at least, but I'm going to be cutting this apart so I can drill a series of holes and use a nail to check my wall thickness as I go. At this stage of the project, my goal is to achieve smooth surfaces with a consistent wall thickness of about 3/10 of an inch. Using this nail with the tape indicator, I can go along my wall thickness here and check at the various holes. Here you can see I've got an extra 1/8 of an inch of material that can be removed. So I turn a little, check, and so forth until I get consistent smooth walls all the way through. At this point I've got my wall thickness where I want them to be. I'm going to reverse mount this, but this is my last chance to sand, so I'm going to take this down to 400 grit. I placed the blue tape on there just to temporarily protect that future glue seam, and now I've got one last chance to inspect these surfaces. To reverse mount this, I'm going to use a large jam chuck. This is 4 layers of MDF, 2 layers there on the outside. It's a very stable construction. It won't vibrate much. Turning a groove, testing that fit. I need a nice snug fit. I want this perfectly centered. Once I've achieved that, I'm going to put a bead of hot melt glue all the way around that seam, and then I can go back to the lathe and turn off the MDF waste block and work on that last curve to complete the turning of the project. It's obviously very important that I did a good job of centering this, and it seems to be so. So I can take off the faceplate now, get rid of all this MDF, and start working on this last quadrant of the shape, getting everything nice and smooth. Now the first step would be to get rid of all those stair steps. So I'll just go at this, get it smooth to the touch first, and then I can start checking those wall thicknesses with the nail and the piece of tape. Now, like I said, this is the only chance I get to work on this wall thickness, and it is important that it be accurate. I'm now satisfied with that wall thickness, so I'll proceed to sand everything that I can reach with my power sander, and I'll sand those other areas by hand. It's my habit when I'm doing any sort of sanding like this to blow off all the dust occasionally and do a real close inspection with a bright light. Now, to get this off the jam chuck, I'm going to use this piece of MDF to secure it. Then I'm going to very carefully remove the majority of that hot melt glue. This is no time to get very aggressive. I don't want to make any scoring marks on my walnut because that's going to be part of my final form. Now, to get the rest of that hot melt off, I'll just carefully scrape it off with a utility knife. Using the drilled holes as a guide and the segment seams on the other side, I'm cutting this into 2 half pieces. And now I'm taking those half pieces and cutting about 1/3 off of each one. My challenge now is to take those larger pieces and try to figure out a way to slot the upper portion, the neck portion. This is going to require some tricky bandsaw cutting and some trial and error fitting, but my effect, I think, will be worth the trouble. I'll put these together multiple times until I get these slots, big enough and so forth. Here I'm getting pretty close. It comes together. The slots need a lot of cleanup work, but I'm getting pretty close to my desired effect. So to do that cleanup, I'm using a variety of tools, a die grinder, checking and fitting, and then I'm going back and forth with various tools. Here I'm using a grinder with a coarse grit sanding disc, just rounding the corners and so forth. A Dremel tool comes in handy, and a large 5-inch diameter sanding pad. Things are starting to look pretty good. Now, those overlapping seams would be very difficult to finish after this is together, so I took advantage of my ability to finish it beforehand. I even put some ink on the edges while I had easy access. To prepare for that final glue seam, I first protected the edges with blue tape, and then I'm creating a series of glue blocks with Gorilla Tape, a little scrap of wood, and a piece of double-sided tape. I'm going to put a whole series of pairs of these on opposite sides of the seam so that I've got a place to anchor rubber bands to. I'll place these about 3/4 of an inch from the edge, so during the clamping job I've got something I can wrap some rubber bands around. Now I'm creating quite a few pairs of these anchor points. This will give me plenty of clamping points with my rubber bands. I'll take this apart now, spread an even coat of glue on both surfaces, and then put it together. A rubber band around the entire end, both ends, will provide plenty of pressure towards the inside of the seam. And then I'll go to work on those anchor points. Just a rubber band or two at each point closes up and provides the clamping pressure on the outside of the seam. I'm also being very attentive to keep those surfaces very flush to one another. That will minimize my cleanup later. I've now got my ribbon bowl in one piece. Removing the glue blocks and the rubber bands is pretty simple. There is a little bit of tape residue that remains behind that will have to be cleaned up. Now, to clean up the glue seam, that's pretty simple. A 3-inch power sanding disc, and then on the outside I can use a palm sander. I want a very smooth transition on either side of that glue line. I've signed on a particular segment, and now I'm cleaning it, getting ready for multiple coats of finish in those areas that were not finished prior. Before applying the last coat of finish, I also blackened the remaining edge to match what I'd done earlier. I subtitled this lesson, A Real Head Scratcher. It does have a fairly high degree of how'd he do that? Well, I hope you can take this technique maybe in a new direction. Have fun with it. Try to advance the art of segmented wood turning in your own way. You might be wondering what happened to those cutoffs at the bandsaw. Well, this little guy'd like to say hello, and just to show you that those cutoffs didn't go to waste.